This is an interesting question for all of us. Are respins a fact of life? It will be moderated by Pradeep Salla, who is a senior tech manager with Mentor Graphics and the general chair for DVCon India 2021. Over to you, Pradeep.
Thanks, Shreya. I've been looking forward to this panel for a while, and we have a very interesting panelists here. So let me get started and introduce the panelists. First on the panel is Sumit Goswami. He's a senior director for EDA methodologies at Qualcomm. Sumit has over 2 decades of experience in semiconductor industry and is known for building high performance teams and delivering cutting edge SoCs. He's currently responsible for driving tools and methodology for silicon design in Qualcomm. He joined Qualcomm 9 years back and played various roles in India engineering team. And before that, Sumit has had stints with Intel and also started off his career at Synopsys. And I can keep talking about Sumit for a while. He's got an illustrious career, and looking forward to his time here and on this panel. The next panelist is Malay Vyas. He's a senior director for systems enablement at ARM. Malay has more than 23 years of experience in semiconductor domain. He is currently the senior director for systems enablement at ARM. He's responsible for system integration, performance analysis, system verification, emulation, FPGA, and hardware platform design. He's also the co-developer of ARM's IP verification strategy. And prior to that, he's worked at AMD, TI, and Montalvo Systems. And he has extensive experience and exposure to CPU and system SoC verification and emulation of FPGA technologies. Welcome to the panel, Malay. Our next panelist is Amardeep Punhani. He's a senior director at R&D for NXP Semiconductor. Amar has overall 22 years of experience in the VLSI industry. He has been engaged with automotive SoC and IP development in NXP for the past 13 years. He's done various roles of SoC chip lead, global digital IP manager, and now a senior director of digital design. He's been involved with development of multi-billion gate SoCs meant for automotive and edge-based system solutions. And before NXP, he's also worked in various capacities as with Agilent Technologies, NEC in Australia, Altima, and Amar, a warm welcome to you for the panel. And our last panelist, and not the least panelist, is Harry Foster. He's the chief scientist for verification at Siemens EDA. And he's also the co-founder and executive editor for the Verification Academy. He holds multiple patents in verification and has co-authored 6 books on verification. He was the 2006 recipient for the Accelera Technical Excellence Award for his contributions in developing industry standards and was the original creator of Accelera Opal Verification Library. Harry just served as the DAC Executive Committee and the 2021 DAC General Chair. A warm welcome to you, Harry.
Thanks.
So, let's get started on this panel. I'm just rubbing my hands and just eager to get started. So, to set the context, despite more than a decade of effort in establishing new verification methodologies and technologies, right? The problem of how to produce functionally correct ASIC or FPGA-based electronic components is still a challenge. And we see that about, based on various surveys that Siemens EDA has done on the Wilson research, we see that over 2/3 of the projects surveyed, both ASIC and FPGA are completed behind schedule. A cynical observer might say that 1/3 of the responses were actually lying. There's no two ways about it. We've seen the vision talk and the keynote speaker talk about the challenges that are coming our way with verification. So, while the design and are getting complex, our verification methodology hasn't, remained static over the years. But then, the problem is that as the design complexity grows, according to Moore's law, verification complexity grows at a substantially greater rate. So for each of these panelists, I have two questions, and I would hope to hear from each one of them. Uh, so the two questions for each one of you are respins a fact of life? If not, what needs to change? If so, how do we control cost? And the second question is concerning respins, does our industry have a design problem or a verification problem? So Harry, could you please take that one first?
Sure. Let me share my screen real quick and put this in presentation mode. Let me minimize this. All right. All right. So are respins a fact of life? I want to begin with, this might sound awkward, but it's related to both questions. I want to begin with a brief discussion of W. Edwards Deming, and why you'll see in a second. But Deming, he was famous, considered the father of statistical processes and control. He was invited into Japan after World War II and totally revolutionized their manufacturing process. And his belief was that quality can't be inspected into a product, it must be built in from the beginning. To illustrate this, by the way, he used to give these lectures where he would divide the class into two groups. One group, both groups, by the way, he would give this box full of white beads and sprinkle some red ones in there. And then he would give each group a paddle, and the goal was to get the red beads out. Now, he would reward one group that got the most beads out, and he would penalize the other group that got, left a lot of beads, essentially. And at the end, the lesson was don't put the red beads in there in the first place. Now, that might sound simple, but it is something that we have to think about in terms of design. Today, there's different cost multipliers associated. And you can argue, I disagree maybe with these cost multipliers. This is based off a discussion with a couple managers. They're doing 5 nanometer ASICs. You can see from, if I find the bug essentially where I'm coding, it's significantly less than if I find where I have to go through a respin. Essentially, that's what it's talking about. So how can we improve RTL quality? Um, well, our goal, if you think about it, is to reduce bug density, and this can be done by intent, focus, insight. And I view this in terms of three pillars. I mean, again, our goal is to obviously eliminate respins, but also we want to eliminate that bottleneck and the cost associated with finding bugs later in stages. So I view this in terms of three pillars. One is what I call the produce pillar, and this where it involves producing the correct intent by construction. There's a couple ways we can do this. One is IP-based design, but there's a bunch of issues associated with that, which hopefully we'll discuss later in the panel. The other is more efficient ways of doing design, which I'm going to go into that in detail. The other is what I consider the prove pillar. And let me give you an example here. This involves basically automatic techniques, static and formal techniques with low overhead. There's low involvement from the designer's perspective. It's not like writing assertions and formally proven. The I was in a discussion with a high performance computing manager. They had an ASIC where they had done billions of cycles of simulation, and a bug got into silicon. And when they went back and looked at the root cause of the bug, they actually could have found that bug if the design engineer had simply ran lint. Now, this seems like a really outlier in terms of bugs, but you have to think about it. The sooner you can find the bug, the less the cost. So that's the third pillar. And there's various pieces involved in that. Traditional lint, but there's also these formal apps, X optimism, pessimism type apps, RTL clock domain checking, reset domain checking. There's a bunch of things that can be integrated into the flow in a seamless way. that will identify these bugs right up front. And then there's a protect phase. And again, this is maybe using things like netlist CDC, again, to ensure that we haven't introduced errors as we start to integrate things. Okay, so what are some other ways that we can prevent bugs? Well, one way is that there's, by the way, there's this constant in software that has been observed, and it doesn't matter what software language you're using. We see roughly 15 to 30 bugs per 1,000 lines of code. I actually know some managers that actually track this metric because they're expecting 15 to 50 bugs per 1,000 line of codes. And again, it doesn't matter what language is being used in software. The true is, it's also true with RTLs, such as Verilog, System Verilog, and BeachDL. Now, if we were to move to higher level language, we would still have 15 to 50 bugs per 1,000 line of code, but we have less lines of code. You can think of 100 lines of HLL is equivalent to about 1,000 lines of RTL in some cases. We would expect a 10x reduction in the average number of bugs. So that's 1 to 5 bugs for high-level language versus 15 to 50 bugs for RTL. That is one way that we could reduce bugs. The other advantage we get in terms of higher level synthesis, higher level languages is a significant speed up in terms of simulation performance. Now, we cannot move everything to higher level synthesis and higher level languages, but it is one step. It's something that needs to improve over time. Ultimately, we're doing design at a pretty low level, and that's one of the things that's going to be necessary for us to solve to close the verification gap going forward. Other things we can do is have design environments where we're inputting the RTL that is actually checking and finding bugs as we input it. That's pretty critical going forward. So my position statement, are bugs a fact of life? Well, the data suggests that. If you look at the Wilson Research Group study data that goes back to over 20 years, it's always been only about a third of projects able to achieve first silicon success. And many of those projects, there are incremental changes, not significant changes in the design. So to some extent, yeah, they're a fact of life. The question is, how can we reduce cost? And we actually have quantitative data that shows that projects that are mature and their verification processes do better. And that quality cannot, this is really my main position statement that answers both questions. Quality cannot be inspected into a product, it must be built into it from the beginning. RTL quality can be improved through intent focus insight, like what I presented just a second ago. And with that, I will yield back.
Thanks, Harry. I think we'll get back to some of the interesting that you talked about. But Amar, do you want to go next?
Sure, Pradeep, and very excellent insights shared by Harry. So, hello everyone again. This is Amardeep Punhani. I am from NXP and have been working on the digital designs for 20 plus years now. So a lot of this is my personal views in terms of what we have seen in the past. So I'll go straight to the question because I think Harry laid a very good foundation on how things are essentially and what is the basically complexity we are seeing coming towards our way in terms of the various various designs that we are seeing. So my view on this one is that are respins a fact of life? The answer is an emphatic no. Respins cannot be really considered a general thing in life which we have to live with. And the primary reason for that is that the cost of defects is just way too high. Today, if we see, especially in a 5 nanometer world, the mask cost that we have is actually huge. That is what leads to challenges. The other is that if you look at designs like automotive or the automotive, aerospace, etc., the cost of recall is extremely high, and we are talking about defect parts per billion rather than million at this point in time, which requires a different paradigm in terms of quality. And and if we have simple defects making our way into the silicon, that is something which is just not acceptable. The other thing is that design teams must move on. The designs are larger. The teams that are engaged in the project are larger. The issue could be on a simple, a simple defect somewhere in the corner, but then the whole team gets engaged, and that's a significant problem which we need to be able to solve. Right. So we again, need to find ways of how we can avoid these respins. Clearly, we need a holistic view to improve quality, and we definitely need better tooling. When I say holistic, it has to look at the hardware software picture together. It has to look at the mixed signal. It has to look at the pre-silicon, the post-silicon, and various associated aspects, which could be as simple as a link, what Harry was talking about, or it could be a very complex corner case scenario that might not show up in our verification and validation setups. Now, clearly, when we get into these kind of design and verification aspects, the question is, how essentially do we control the cost? Now, we know that a lot of the respin that we are seeing around us is driven by many of the analogish aspects, many of the reliability aspects, many of the technology related aspects, and the yields could be low and things like that. But given the discussion here today, the intent is to focus mostly on the digital side of things, and because I think each one of these are very large topics to be able to do justice in this 1 hour. So my focus definitely is on the digital aspects. So one is that co-design and co-verification, I think, become a very important piece. The software is playing a very vital role in the whole setup today. If you look at the cars, I think we've been saying this in various at various levels that, and it's a known fact today that the software that goes into a car is actually much more than a passenger airplane, right? So, and many times larger than that. So we just cannot ignore software. And software along with hardware, it's a must-have that from the very beginning itself we are doing co-design. We are ensuring that the hardware and software teams are talking the same language. And in many of these organizations, we have seen that this has been after the fact. But now, of course, huge realization in that area, and I think something that we need to continue with. And we need better opportunities to be able to do a co-verification of those aspects as well. Pre-silicon, I think, cannot be focused enough, or cannot be emphasized enough that emulation and FPGA play a very vital role. The methods and the techniques that we have are very advanced at this point in time. Clearly, there is more opportunity, but pre-silicon is the way to. Often we end up in a situation where the mixed signal that we have is highly analog focused, but analog digital aspects, are we taking care of that in our test chips? That is also one of the key areas that eventually, if not taken care of early in the cycle, can lead to bigger issues at a later point in time. From the design side, what I would say is that I think we should not underestimate the value of 3x5 bias. In variety of the engineering discussions that I have been to, we see that yes, everybody says, okay, RCA is to be done, but are we doing effective RCAs? Are we doing RCAs at the right time? Are we prioritizing the defects enough? Be in terms of I think as Harry was saying earlier as well, that at what stage you find the defect, the cost significantly varies. So we need a culture within the teams to be able to have a 3x5 bias starting from the engineer level itself and not at the higher level. I think that's a important aspect. A lot of us talk about it, but I've seen that any of the teams that have been able to do this have really been able to make a mark on quality. And last but not the least, I'm not sure if the right forum to say this here, but I must say that the EDA industry, I think, must step up. We are seeing that in many of the areas there is catch-up mode, which we need to find ways of avoiding. And then, of course, we must use the AI/ML solutions as much as possible. We need innovative methods. A lot of innovation is going into the EDA, huge amount going into it, but clearly, given the complexity, that is not enough, right? So we need more of that. Now the question often comes: is it a design problem or a verification problem? My problem is, I mean, the point that I have to say is that, you know, who is taking sides? Should we really be taking sides? It is a combined problem. It is a design and a verification problem together. And, you know, me having worked on both, and, you know, having teams from both from the design and the verification side, I think I can say this very very clearly in my mind that both the teams have to step up to be able to resolve this challenge. On the design side, we often talk about correct by construct. That is the mantra. That has to be the mantra, and it has to continue, because there are many techniques that we can use within the design so building in the quality, as was being said. We can use the right constructs. We can have smaller designs. We have the right partitioning of the designs, and many things can be done. But it only goes so far, because whenever you build something, you will end up introducing bugs into it. So, but verification is definitely a cost and schedule driver. It is, and it is significantly increasing. If you see over the past, past few years, there has been a huge amount of growth in the verification resourcing that we've had to put into the designs to get them through. Now, the question is, do we have the right skill set? It requires a very different kind of skill set than just to be able to have somebody totally relying on the tools to do this. We need the right verification skill set, be it in engagement early on when the new graduates are coming in at that point in time, with the right trainings and so forth. But this is a different mindset that is needed today for the verification to happen. We can probably talk more about it as we go forward. So like I said, we need the tools, but we need the mindset first. And clearly, some of these tools, for example, if we talk about safety and security, which is becoming a key problem area, if we talk about just the coverage scenarios, which are becoming a huge problem area today, interestingly, we see that 20% of the team's effort is going into just closing the coverage. 20% of the overall development time. That's huge. I mean, can we do something in terms of the innovation just to be able to get the tools right in that area? So plenty of opportunity in various categories. But yes, I think it's a combined design and verification problem. Yeah, that's brief from my side.
Thanks, Amar. I think that's a pretty good list there, and I'm sure we'll come back to a few of those things that you talked about a little later. Malay, do you want to go next? You're on mute, Malay.
Yeah. I'm just trying to share. Right. So, can you see my screen? Yeah. Okay. So, so interesting points put by Perry and Amar here. Good morning, everybody. I'm going to probably expand on some of those things, and this is very typical three-pronged challenge we have in the domain, right? You want the lowest schedule, you want the lowest cost, and you want the best quality. So if you put a volume under this curve, you want the most optimal shape. But the moment you start pulling the quality to the higher side, schedule get pulled up, or cost will get pulled on the right, and that's the challenge. Some of the points made by my fellow panelists here around hardware acceleration, kind of divide and conquer, right? Basically, split the design, go to the smaller thing, mathematical model-based approach. I think these are all lot innovation happened over the last, I would say, 20 years or so, and there's a lot happening there. So it's all looking good. Our Respin fact of life, it's a very, I would say, heavy statement when you say fact of life. I would say it's going to be context driven. And I would just make one point around the context is your design special purpose or general purpose, right? And when I say special purpose, you kind of know your use cases. You know exactly what software you're going to run on it. There is significantly higher probability of you getting it right as compared to a general purpose microprocessor, like what you do at ARM, for example. You would say, you won't know what is going to run on it. right? So you are going to take your best guess and best approach, try to do as much as possible, but there is always something you're going to miss. So I think that's one of the most important aspect to keep in. So respin are kind of really a probabilistic thing. It's a context-driven thing to me. You can up or pull it down in terms of probability by doing different things. And one of the things which at ARM we started looking at in the last several years is what we call shift left. That goes back to Harry's picture of intent and various phases, right? But could you try to do what is most important in a more denser fashion in the beginning, right? And that is going to really, your total area under the curve is going to be the same, right? Total effort you want to put is the same, but could you focus on the priority? And this comes with experience. This comes with building many products over the years. You will know that these are the areas where, as an example, in microprocessor design, you would say memory coherency is one of the hardest problems. So can I focus on memory coherency as early as architecture, microarchitecture design on priority, rather than trying to treat it like everything else, right? So that's an interesting way to look at it, and I think we can continue exploring in here, basically increasing the density in the early part of your development in a smarter way could help you reduce the probability of respin. So again, I'm going to keep mentioning that I'm looking at reducing the probability. I'm not looking at making it zero, because it's going to be pretty hard and daunting task. Another thing which is important to look at is not all bugs are equal, right? So again, going back to the previous picture, when I go to shift left, can I go and find those killer bugs sooner? Can I figure out ways to do the killer bug? And it goes back to some of the points Amar made about having the right skills, having the right mindset, right? Because running a regular workload versus something which is going to find those nasty memory coherency bugs, this is a very, very different approach. And how are we going to do that? But a lot of the bugs are probably okay to leave in, and it's kind of controversial to say it here in a lot of verification engineers, but in this forum, not all bugs are going to really kill you apart. If that's the case, how do you decide which one to be focused on, and when do you focus on? That's an important skill, which again you get over time. So I think my key take on the first part of the questions put in front is that how it's a probabilistic game, respin, and how do we reduce the probability is the important thing. I'm not going to repeat some of the things already said, but formal is another thing I would just touch upon, is showing a lot of promise if it can scale, right? And if we can really go formal way, it kind of goes back to intent, correct by intent design or correct by construction design much sooner than that. So that's something which goes back to the EDA industry, and we all would look at them and say, can we solve that scaling challenge we have in the formal tool today, right? The second part of the problem, and I will take the same approach what Amar said, is it's neither design, it's nor verification only. I think both are kind of hand in hand. As an example, again, go back to the shift left. If verification shift left, but design doesn't, it's completely pointless, right? So it has to go hand in hand when it comes to whether it's a design or verification. So this challenge is kind of very interestingly, some of you would have seen this particular, it's kind of a meme which says cheap, good, and best. These are the three features, and you can take only two of them, right? So which means if you take cheap and good, it won't be cheap, good, and fast. So if you take cheap and good, it won't be fast. If you take cheap and fast, it won't be good, right? So how do you find that balance? I think we are in that point here. So I'll conclude that Yeah, it is. It is something which we can avoid by various techniques, but primarily we can, at this point, we can reduce the probability. That should be our focus, and hopefully, at some point, we can bring it to zero. But right now, I would say focusing on the reducing probability is the key. With that, I rest.
Thanks, Malay. Sumit?
Thanks, Pradeep, and good morning, everybody. And thanks to my previous panel members to set up the stage. And for a change, I thought, okay, let me not bring any foil for this discussion and more talk freely, because there was already enough foils and the context is set. Now the question, this is very interesting question, is Respin is a fact of life? You know, the engineer in me says that it should not be, but the reality is it is. Now need to understand why, right? That's a part. Whenever Respin happens, the traditional thought process is that it is because of a bug discovered. Yes, it is a bug, but what kind of bug? That's important. So very interesting perspective Malay brought on his foils, talking about special purpose versus generic, right? So if you go back to the history, we started designing hardware, which is more like a fixed function hardware. It just does a specific job. It has a very specific purpose for the operations. Now, verifying those kind of aspects are much more easier. Now, more and more what we did that we made those machines programmable. And the more and more it became programmable, we created another ecosystem called software. And once the software opens up, it opens up a platform where people can innovate anything. Once they innovate, I need to make sure each and every condition runs on my machine perfectly. And that creates another. Suddenly, my challenge become a cannon shape, right? Suddenly it started expanding all over. Now, can I verify each and every condition, each and every possibility, what can happen in a programmable platform? Answer is not that easy, and that creates problem number one. So this is, I would say, functionally, this is the reason. How can I predict all the user behavior on my device and validate very early in the cycle? That is a factor number one. Now, what is factor number two? More and more devices becoming battery operated. Now, once you start becoming battery operated, the key KPI for the industry become one charge goes for how much. That means power efficiency become a key. The moment power efficiency become a key, then you bring in a lot of additional features on your design for power efficiency improvement. You bring in something called power states. Now, different part of your design operate on different power states, and there is some power manager which is kind of orchestrating them. Now, this also creates some huge amount of configuration which you need to validate. Now, how do we validate? Industry evolve on the UPA, power intent coding, but designs are becoming a lot more complicated. How the power intent is changing from design A to design B and how it is changing from the various phase of the design, that become a challenge. So power verification become a challenge. Number three is more on the process node induced. We start seeing a new issues in a different process node. Take an example. If we say that in a lower process node, certain types of memory can be vulnerable, can I put additional features so that even if there is a problem on the field, I can repair it and we can avoid a respin? Now to put that all those things, I need to put additional gadget. I need to verify that. I need to make sure that that works seamlessly on the various conditions. So that creates another problem. So if you look at it now today, Respins is a reality. Answer is yes. That may not be functionality driven. Maybe this is driven because of something else. Maybe because of a power bug. Maybe because of a complex performance. Because of that, we have designed a certain timing constraint that is causing some Respins. Maybe this is a yield improvement. But guess what? All of these in inducing some additional logic in my system. Now the fourth one coming interesting part is that the safety security angle of it in the automotive era, right? It is bringing all sort of different in-field guarantee that system is not going to break down when the chip is in operations. You need to put a whole lot of different circuit. You need to put a whole lot of different verification methodology to make sure that it works. So that also creates another set of challenges. So today now, if you look at this historical path, that when we started from a very fixed function logic, then the Respin was a part of life. was yes, in certain extent. Have we evolved from there? Answer is yes, we have evolved. Today, probably we can do it fixed function design much better way than we used to do in past. Can I do the programmable design? The complexity is endless. You can't model it in some mathematical model that all these use cases, what I'm seeing in my real life device, can this be modeled in a very simple test case in my RTL simulations? It's not that easy. Now, what we are doing is that we are doing a huge amount of software testing. Then we are trying to figure out that from software testing, we are trying to isolate some set of bugs and then try to take it in the post silicon, running on a microkernel on that, and try to figure out, can I reproduce that bug? From there, if we can isolate that it's a functional versus it is more like a process phenomena or speed phenomena because of the process or software or whatever it is. Once we can isolate, then we look at it. Can I block it during my ATE time, or do I really need to take it back? If I need to take it back, then I go back and see that do I need to put a feature to block it? This particular occurrence, can I block it by putting a feature? So now if you look at it, this is another source of getting feature, another source of creating problem. But does it solve anything? I mean, is it so bad going into programmable? Answer is no. Today, it provides another hook of workaround. Today, once I discover a bug, add the, do I need to do a respin? Thanks to the programmability, probably I can design a workaround which may cost maybe little percentage of power or performance. Maybe that is so negligible that end user does not even notice that. But can I do that with that? Can I block the bug? Maybe yes, depend on the situation. So answer to this question is that, is it a fact of life? Answer is yeah, yes. But we as an engineer always, try believe that no, one day we'll design a particular chip which is not, in the very first tape out itself, we can productize. Now that is the day where I think we all in the industry, we all are working towards it. If the design is incremental in nature, I think that's what Harry kind of pointed out, because a lot of IPs are today incremental in nature. I think the chances are low. If we put a brand new IP, chances goes high. Now coming back to the second question, is it a design problem or verification? I think I'm kind of agreed with most of the panelists here that it's a balanced game, right? It's a, but what is required, what Amardeep was talking about, that the correct by construction approach, and that is the key. Now, what we need to do is that as an industry, we need to enable each and every functions with additional tools to make it correct by construct. For example, when I'm doing design, can I introduce some static methods? Can I introduce the lint example was a great example what Harry has given. Can I introduce additional static method? Can I manage my changes coming into a design and prioritize verification on the changes first? Can I do some integration issues? The different multi-site environment create different designs at different geographies. I mean, that's a part of most of the multinationals. Once I club it together, do I make sure that everybody understand their intent so that the integration issues I'm taking care upfront in the game? So those are the correct by construction approach. We have to do it in the design process. And in the verification process, our same left shift apply, that how do I take a lot of software use cases to my post silicon, to my emulation, to my RTL, and that's the left shifting need to be done. So I think again, it's a balancing game, and both have a lot of scope of improvement here.
Thanks, Sumit. I guess all of you are taking the balanced way out between design and verification. So we'll come back to that. Is it a design problem or a verification problem? Let's go back to Harry. Harry talked about building quality into the design in the first place. So Harry, what would this look like, right? Is also software included in the solution?
Oh yeah. The problem is that it's a total mindset change. By the way, I think one of the problems our industry has suffered from, if you went back, to the early 2000 timeframe, we did this shift in terms of verification teams and design teams, and part of that was by growing complexity, certainly in the requirements. But that led to an extreme, the pendulum swing all the way to the other way, where all of a sudden it was many projects perceived that I do my design, throw it over the wall, and it's a verification problem. That has shifted back. It's shifted back because of well, that's not efficient to begin with, and as I think as everybody says, it's ownership of both. So to answer your question about the software aspect, that's just one of the pieces. And if you partition this in multiple, basically the partition this down where I can solve and prove different pieces. Sure, software is a big piece. Now I wouldn't want to start with that. Yeah, so as I start with design, I want to find these things and prevent bugs from getting down to the next stage. And I think that's one of the problems we still suffer from today is that if a good, by the way, a good company, a good project always asks the question when they find a bug, could we have found this in an earlier stage? And quite often, some projects don't do that, or else they don't really go to that level. So in other words, I wouldn't want to be finding a software, I wouldn't want to be looking for a software bug right up front as I'm doing the design. I want to prevent many of those bugs right up front where they don't get down when I do total integration and software-driven verification. That's my point.
And I know Amar talked about correct by construction as well and building quality into RTL design. So Amar, what, I know you also manage IP. So what would this look like, right? Building quality into the design itself.
So I think exactly as Harry mentioned, design of course has to take the responsibility when we are separating out the design and verification teams. The design should not get into the mode that I just throw it across the wall and let's see what verification has is able to catch. Design, I think as a building block essentially plays an extremely important role. There are many things that can be solved by a simpler architecture than by having to go into multitude of verification tests being run. I think design partitioning itself plays a very important role. Am I partitioning my design in the right in the right intelligent manner so that the cross coverages required are highly reduced? The various techniques that are already there, for example, keeping the things locally synchronous, globally asynchronous, plays a very important role. The power aspect was being brought out. Now we have seen that mode transitions have become can become such a huge problem, because as soon as you are allowing multiple mode transitions, then the state space for verification significantly increases. Now it is a design and architecture problem that that I do the things more intelligently so that I am reducing the amount of transitions that I'm allowing. Such that the verification has, it can focus in the right areas and not really, getting too much worried about the huge amount of combinations that they have to verify. Then, even as simple as, using the right amount of standard structures, using the right building blocks so that the subsequent teams, the physical design teams and the DFT teams, essentially, they don't really have to come back and ask to design to make some changes, because everything that is happening is rightly from the beginning itself, and all that falls on to design. Right. And I think some of the tools that we have that design teams can also use, the static tools, I think there is, clearly opportunity for improvement on the tools. But if you see the static tools are already able, before the design is going to verification, the tools are able to help the designers resolve a lot of these issues early on. So those and having assertions built inside the design, I think can play a very important role from the design perspective.
Thanks, Amar. I know you're talking about again shifting left. So Malay, this is for you. So are there any unintended consequences of shift left?
Yes, actually, there are, and we kind of learned some of those hard ways, right? But it is, if you shift too far left, right? So you'll find that sweet spot. You're trying to do something sooner than it should be. It's almost like you're trying to get a system level bring up happening when your unit level is still at 50% pass rate kind of thing, right? You could end up into that kind of trap. So that's why I mentioned that shift left has to happen across. It has to start from the architecture definition. You have to really start looking at. So basically what you're looking at is creating denser, interesting events into that part. And it starts from architecture, design, unit verification, multi-unit verification, system, etc. So if you do it too far, you're going to have too many overlaps. To put it very simply, if I define 5 phases, let's say 1, 2, 3, 4, 5, I would like to shift all of them, but I would not like to shift as far as 1 and 3 are going to overlap, because then it starts becoming a problem, right? So you want to shift appropriately enough. And we did have a specific observation here where tons of duplicate bugs found by various people, because you are trying to do same thing in multiple places if you shift it too far left. So now we are kind of really finding that equilibrium point, which kind of helps. So yes, there are potential efficiency challenges if you shift too far left.
Thanks, Amar. Probably now I'll just shift on to the software part of it, right? So, Sumit, this one's for you. In the software world, right? IP use, we have software IP has led to somewhat of an increased productivity. And this is even true for silicon IP on the design side. So in verification, we've talked about various technologies out there, but is it even possible to achieve, reuse of tests and, use of IP methodologies across verification and validation, and maybe to even to post-silicon?
That's a very interesting question. I think today, if you look at it, answer is in a very high level. Answer is yes. And if it is not yes, then probably the VIP industry wouldn't have born. Today, if you look at all the protocols, the chip outside protocols where the one chip is talking to another, most of the protocols have their VIP for verification. Now, what we did in that method is that we standardized the test and we made sure that the devices become interoperable. So take an example, right? If I have my chip is having a USB or PCIe support, I don't know who is the manufacturer, but we have certain amount of VIP to ensure that. So this is the software IP equivalent, right? It is an IP which is ensuring that my protocol is absolutely rock solid before I go for productization. Now the question is that the inner portion, can it happen? Today, up to certain level of standard IPs, what we use, like certain set of buses and all, yes, and those can be used like a verification IP, which can be used on that. But many companies have certain amount of secret sauce in making certain IPs better. Take an example, somebody have a better camera, somebody have a better CPU. Now, can that be totally be exposed to everywhere? Then you start losing the competitive edge on that, because the differentiation in the market between two chip operating in the same problem space, that kind of goes down. So again, it's a balanced approach. Certain things can be done, yes, can be done on the more like an IP way of solving. Certain things cannot. That's where the some of the consortiums and the industry bodies can come forward and try standardizing certain stuff. Because once something becomes standard, then the verification also becomes standard. And then once some standard verification method is there, that can be then used. An EDA company plays a big role in making sure that that standard piece of software in going across companies to make sure they talk to each other. And that's how today all the protocols are standard, right? But inside the chip, all the different components, can that be standardized? I'm a bit skeptical on that.
Amar, what's your take on reuse of tests and verification components?
I think that's a very, very important piece, and we are talking about reducing the cost, and I think this plays one of the most important roles there in terms of ensuring that the teams are not having to rebuild the test cases, not having to rebuild the stimulus, wherever it can be avoided. And we're talking about the reuse from the IP level to the SoC level. That is important. We are also talking about reuse across the platform from the simulation to the emulation and the FPGA level. I think all of these things play a very, very important role. We talk about IP reuse. That's a must-have today in wanting to build the SoCs with a reduced cycle time. But just the IPs obviously won't cut the deal here. We need the VIPs for the purpose. We need the as far as possible the test stimulus. We are even talking about having the So in automotive designs, we talk about traceability reuse, right? For example, at the IP level, if I've already done that, we are already bringing all of that together at the top level, so that essentially nothing is repeated. We've seen in the past that when you look at the SOC tests versus what is done at the IP, should I be repeating even any of the items? Absolutely not, right? So we need to look at that the overlap is actually minimal, only probably at the use case level, so that the integration aspects are taken care of. But all other items, I think, can be eliminated, so that we can have a holistic verification with limited effort.
Thanks, Amar. And I think today's theme this morning has been intelligent edge. So if I don't bring intelligent edge into one of my questions, I would be crucified. So, with intelligent edge, we have layers of complexity coming in, right? And not just the hardware complexity, but also on the software. So Malay, this one's for you. So when you talk about layers of complexity on both hardware and software, we talked about, partitioning, right? Be it for the hardware, software across all these domains. How much of those are driven by requirements, and how do you manage that complexity during the partitioning?
I think, again, if you look at the edge compute and the whole domain, it's fairly new. So we have a huge amount of things to learn there, I would say, right now. What we are currently doing is going the traditional approach, how we do the partitioning. But I think with the domain demanding a lot more software-driven thing there, I think we are probably going to find a different balance. That's my view. It is something EDA tools can help us with, right? And I know that's where there's a strong push from EDA on that, because a lot of these things are going to be very, very hard to do manually, almost near impossible. It's daunting. It's like in 90s, you would have asked people to do full synthesis design. They would have probably said, no, I'm going to do hand place my design, right? Versus now, if you ask somebody to do hand place design, they'll say, oh, no, I'm going to use the tool. So I guess here we have to start with the tool. We cannot go with an approach where we say, okay, let's go and try to figure it out. So I think based on the heuristic, whatever knowledge we have, we should start building the tool. But keep in mind, this is a very, very new space, and we have probably a lot to learn. So I would not be surprised if what we think is true today would be completely turned upside down in probably say 5 to 10 years time, right?
Thanks, Malay. So, Harry, I would like to hear your views on, on the complexity of different layers and multi-domains. On, how do you see it playing out? Especially that since Malay mentioned, this is where EDA needs, the design community needs EDA's help.
So I by the way, I think it's also related to the reuse aspect, by the way, on this in terms of the different uses. One of the, I guess, dreams is that we could take IP that's been verified, right? And this could be at different levels, put it together, and it would work. That's not the case. And the reason it's not the case, whether I'm dealing with hardware or software in terms of components, I've got essentially state in this that interacts. And essentially I have a distributed state machine that involves either software state or hardware state. That's what really drives up the complexity in terms of verifying the IPs themselves, whether they're hardware and software. So you can't get away from that. And I do agree with Malay that this is certainly an opportunity in terms of new development, new tools in this space. This is, by the way, what has been driving, just really the incredible growth in terms of emulation today. Is the fact that we're having to verify these different levels, and we can't accomplish that in simulation today. But we need smarter tools in combination with emulation going forward.
Thanks, Harry. I thought you were going to mention a digital twin there, but never mind that. I think in the interest of time, I can keep asking because this is really interesting. But I think we just have 5 minutes to go. So in interest of time, I'll have one question where each one of you, if you could take just a minute to talk about it, it'll be great. So if you could solve one technical problem that's leading to respins today, what would that be and why? Sumit, do you want to take that one?
Yeah, I think if you need to be really, if you actually Harry kind of touched upon, right? Probably how do I connect my RTO to software? I think that's something, if we can do that, all the system today, if you look at it, most of the bugs are because of some of the system level use case. It is not that majority of the core bugs are coming in. Is there any way I can replicate system level use case at my core level, and I can simulate that in a reasonable time? And with that, verify my IP, that would be the one thing I would be go after.
Thanks, Sumit. Amar?
So let me speak something different, because we should give more problems to EDA, right, so they can solve them. If there is one problem that I need to solve, I would say we need more intelligent coverage closure tools. And the reason I say this is that as I was saying earlier in the call, 20% of my IP development effort, if that is going towards the end in just the coverage closure, code coverage 100%, functional coverage 100%, and so forth. We have techniques, but clearly they are not enough, and a lot of effort is going into that. We need intelligent solution. We need solutions where probably we can have automated stimulus generation. We need more machine learning coming into this one, so that that time essentially get significantly reduced.
Thanks, Amar. Malay?
Right. So I would say, again, go back to my point earlier. It's about killer bug hunting, right? I think there is a lot of opportunity for probably tooling to now adapt machine learning techniques and technology to go after specific design areas for the killer bug hunting. So if we have a kind of a soak or stress testing flow, which is really going after bugs, right, through some tooling, I think that's something which is very, very critical, especially for designs like processors, right? Because that's really the key one. Yeah.
Thanks, Malay. And Hari?
So, by the way, I agree with everybody here, but I like what Amar was saying about one of the biggest challenges is related to coverage. And I also agree with Malay in terms of there's certainly opportunities there in terms of machine learning to help us out in that space. But I also believe from a research perspective, we are lacking appropriate fault models at the system level. We don't really have a system level notion of coverage. We have all these other techniques that really are not appropriate. So if I had a wish list, it would be to solve that problem, figure out what would be an appropriate fault model from a system perspective.
Thanks, Hari. So, we can keep going on. I think maybe we can probably schedule something next year as well. But I think my key takeaways from this panel has been, are respins a fact of life? The big answer is it depends, right? A multitude of factors. It depends. Is it a verification problem or a design problem? I think nobody took sides, so we'll call it write down. It's a balance. It's a combined problem. But I think one key takeaway is there's a lot of things to do. Both the EDA and the design community together, and we have a lot of problems to solve. Right? It's just not one. It could be the coverage problem. It could be the multi-domain across complexities that are coming in the next generation. So with that, we have quite a few things to do. Hopefully, and I'm part of EDA, hopefully we are able to address a lot of those challenges sooner than later. And with that, I would like to thank all the panelists for their views and making it lively. I didn't have to break up any fights, so I'm glad about that one. So thanks a lot for all your points and your views. Thanks, everyone.
Thank you. Bye-bye.
Thanks.
Bye-bye.
Thanks.
Thank you. Great pleasure to be here.
Thanks.